I'm Matt, the Choptank Riverkeeper with Shore Rivers, and we're out here today on the Choptank River collecting water quality samples for our tidal water quality monitoring program. This is the data that we collect every year at over 200 sites throughout all of our rivers on the eastern shore, from the Choptank up to the Sassafras. And we use this data to inform our water quality analysis. So the report card that we put together every year includes this data, which is a snapshot and a look at what the conditions were for this season through that data. We also use this information to help inform restoration practices and policy initiatives, and where we should be focusing our efforts in areas that have some of the worst water quality, so we can help to improve the conditions there. Here I have my YSI meter, and on this has a variety of different probes that are going to tell us information from the temperature of the water to the dissolved oxygen conditions, salinity, specific conductivity, and then the depth that we're reading this at. So what we'll do here is toss this in the water at the bottom of the water column so we can get the conditions that are occurring down near the bottom. So we'll lower it down, in this case to about 10 or 11 feet. So we want to hit the bottom of the water here and then come up about 1/2 foot to 1 foot. And this allows us to understand what the conditions are there at the bottom of the water column, as I said. And the reason we want to know that information is because a lot of times we'll see a difference in salinity, dissolved oxygen from the bottom and the top. And those can tell us different things, such as if we have high oxygen at the top of the water column, we could see an algal bloom occurring. That could be indicative of an algal bloom. If we get low oxygen at the bottom of the water column, that could also be the signs of a dead zone, where algae has bloomed above in the water column and then has died and started to decay at the bottom of the water column, where a lot of oxygen is consumed in that decomposition process. So looking at our readings here, which we'll record on our data sheet, so the sample depth that we have is 10.1. The temperature here is 28.5 degrees Celsius. The dissolved oxygen percentage is 73.5, and the dissolved oxygen in milligrams per liter is 5.39. So that's a good oxygen reading for the bottom of the water column. We start to see stressors occur when the oxygen gets below 5 milligrams per liter. And so the fact that we're at 5.39 is a sign that we're in healthy conditions for fish and other species to inhabit this area. And then the salinity here is 10.37. And to put that into perspective, we're here on Island Creek, which is around the mouth of the Tredaven River, towards the lower part of the Choptank River. So 10.37 is right on par with the salinity that we'd like to see in this area. So once we get the bottom reading, we'll then wrap this up and come up to the surface, where we'll strive to get a reading at about 18 inches, so about 1.5 feet below the surface of the water. So I can pull it out here and then drop it down. It tells us right on these meters exactly how deep we are for that reading. So there we are at 1.5 feet for our sample depth. And the temperature here is 29 degrees Celsius. Dissolved oxygen percentage is 86.7. Dissolved oxygen milligrams per liter is 6.32. Again, above that 5 milligrams per liter threshold that we're looking for. And the salinity is 10.34. So the salinity is pretty equal between the top and the bottom. Typically after rain events, you'll see the top of the water column have lower salinity levels, because you have that fresh water that's coming off the land and into the water, and you get sort of a stratification there. And the dissolved oxygen varied a little bit between the top and the bottom. We had 6.32 milligrams per liter at the top and 5.39 milligrams per liter at the bottom. Again, both above that threshold, and we would expect to see a difference in the top and the bottom, like we see here, given the depth that we sampled at. So that's how we use the Pro DSS YSI meter to collect those parameters. And now we'll show you another parameter. All right, so here we have our Secchi disc. This is the instrument that we use to measure water clarity. So what you notice here is the black and white sections of the sphere. You'll drop it down into a shaded part of the water, so you want to have it shaded, and you'll essentially drop it down until you can't see it anymore. And the method that I like to use best is to go down till you can't see it, raise it up again till you can see it, and then give it one more drop down so you are a little more certain exactly where that is. Go ahead and pinch it off the water there, and then we measure here. Here is a 1 foot increment. Here's our 2 foot increment. So we're just below 1.5 feet. So we'll call that 1.4 feet of clarity, and that we'll put on our data sheet. Collecting our nutrient sample. So we have a 60 milliliter bottle that we use to collect this sample, and on it we have the site that we're sampling at, which is LI01 for La Trappe and Island Creek, and then the date, July 7th, 2021. The method here is you want to rinse the bottle at least 3 times, and the way to do that is fill it up and then deposit that water in another area so you're not picking up that same water in your sample. And then on your 4th one you can go ahead and fill it all the way up here, and then we need just to leave a little room because these samples will get frozen. We want to have some room for them to expand, so we'll go just below that little area there, and then seal it up and then put it on ice immediately. We're going to collect a chlorophyll sample, and like the nutrient sample, we're going to send this to the lab for analysis. So what we have here is a plunger that helps us extract a certain amount of water from the river, and then in this little capsule here is a filter. And it's actually the filter that we want to use to send to the lab for analysis. And so what we'll do here is we'll secure that filter, go ahead and we'll pull water into the plunger, and just like the nutrient sample, we want to rinse this a couple times with the water that we're taking from the site that we're taking the sample. So we'll go ahead and do that 3 times. And then on the 4th one here, I'll collect exactly about 60 milliliters is what we want. So I'll go ahead and drop that down. You can see we have 60 milliliters there. And then you go ahead and you attach this capsule here with the filter in it. And then holding it straight up and down like this, we want the water to go onto the filter evenly. So we go ahead and we push it down. And we do that all 60 milliliters. You can see here, sometimes it takes longer, sometimes it goes quicker. It really depends on how much material is in the water column. Make sure you get it all through there. And then as you can see here, take off the capsule and you'll see all the material that we have that the lab will be able to analyze. Prepare this filter here to send it to the lab. And so what we do is we take the capsule apart, and with our tweezers here, we want to take the filter off. You want to do it as smoothly as you can. Take it here and put it in this filter, in this tin foil. And you place it on the fold there, and you want to fold it on itself like that so it preserves that material that we collected. Go ahead and seal up the sides on each side of that so when we put it on ice, nothing gets in there. And then on the label, or on the foil itself, I have the site identification number, the date, and then what's important is how much water we push through that filter to collect that material. And so we put 60 milliliters of water there. And so this will, again, go on ice as soon as possible to help preserve that sample. So just a reminder, chlorophyll is important because it is an indicator of how much algae is in the water system. And so we know that when we get a lot of nutrients in the river, like the sample that we collected, which we'll analyze for total nitrogen and total phosphorus, when we get a lot of those nutrients in the water system, you get a lot of algal growth. And we've had a long history and actually an increasing amount of algal blooms occurring on our rivers. And so it's important to understand when these are occurring, what the conditions are that are causing them to occur. And so through this analysis, we'll be able to better understand that.